Hello everyone, welcome to another problem session. So today we are going to talk about work, but work on ideal gas. So there is a, over here you can see that the volume is in liters, and this is pressure is in atmospheric pressure, in units of atmospheric pressure. A liter is 1,000 centimeter cube, and you can say that 1 meter cube is 1 meter times meter times meter, and each one of them has powers of 2, so 10 to the power 6 centimeter cube. So a liter is 1,000 of that. So a liter is just like right between 1 cc and 1 meter cube. Okay, so what are we supposed to find? So first we're supposed to find work in each one of the steps, like A to B, B to C, C to A, and over the entire cycle. The second thing we need to find is heat involved in each step. So how much heat was involved here? I would tell you that this is like a heating, this is heating, and this is cooling. That's how this will work out. And then we're supposed to do the heat for the entire cycle. Okay. So in terms of work, let's do the work first. By definition, work is a small amount of work is equal to minus P dV. P is a function of V sometime. So this is for any small step dV, amount of work that will be done will be this. And this is, we use work on gas. So our notation in physics is this should be positive when you're contracting, and it's negative when you're expanding. That's a physics thing. In physics, we do it that way. In chemistry, you do dW by gas, and that will be plus P function of V dV. So we'll use this for each one of the steps. So what will we get when I do an AB? Well, it's just going to be this integral from VA to VB P dV. But the integral is also area under this curve, right? So P is a function of V is that. So this is 0. So if you just think in terms of integral, this area is what this will be. So this will become minus, and because expanding is going to be negative work, because energy will be taken out by this work, and this will be just 1 atmosphere pressure times the volume change took place 20 to 40. So 40 minus 20 liters, and so this will just be minus 20 liter atmosphere. We can convert this liter to meter cube and atmosphere to Pascal, and that should be minus 20 times 10 to the minus 3 to go to the meter cube, and 10 to the power 5 to go to Pascal. So meter cube Pascal, and this should be same as joules. So we get you can see this will kill one of these. So 5 minus 2 will be 3. So minus 2000 joules. That's what will go to A to B. How about WB to C? Now there is no volume change in any of this, so every one of these pieces will give me 0. So this is very easy to see, that dv equal to 0 at each point. So that just gives me, and WCA, well, it's going to be this, it will be this entire area. So we already know this area, and this is dv is negative. dv is negative, so it's going to be turn out to be minus vc to va p dv. Of course, you can write down p as a function of v on this line and do the integral, or just do the area. So this is going to be plus this, because this is negative, this can flip our sign, and then this plus area, and the area will area under curve, PV curve, right? So this area is you can see the area of this rectangle plus the triangle. So area of rectangles we already found out is 1 times 20 liter atmosphere, just like this. It was negative there, but it's going to be positive here. Plus triangle will be half times height will be this height, and this height is 2 atmosphere, and change in that is 20. This also liter atmosphere. So this one is also exactly same amount actually. So this is just going to be 40 liter atmosphere, and you can see that when we are at 20 liter atmosphere, we got a 2000 joules. So this will be 4000 joules. So what's the work in the entire cycle? So work in this our cycle is just sum of the steps, and so it's going to have 2000 joules plus 0, that minus 2000 joules, very important, the negative sign, because expanding, and 4000, so that together becomes plus 2000 joules. So I have to do this much work to go through the entire cycle. Okay, so we're done an A. To do the B, find heat involved in each step. Well, let's clean this up and let me talk about that next. So if somebody's asked you to find heat, while you already found the work, then you could do heat directly. So remember, so Q directly has several formulas. You know, remember Q is equal to mc dt, the temperature. You can integrate that. There are several formulas, this and ml. This is specific heat transformation. So you have these formulas at your disposal to get heat in any process. But when you have work already figured out, so say I'm looking at A to B process, and so we already figured out WAB, and if first law says delta U in this process is equal to Q in that process plus WAB. So you can see I can find the Q if I can find that, right? So the Q in this process simply will be delta U AB minus WAB. So we already figured that out. So if I can find this, if we can find this somehow, then this may be another way to get how much work is involved in this process, right? And turns out that for ideal gas, because this is theory, and actually from so-called kinetic theory of gas, you can prove it, but gas, and you can see in some books like in physics boot camp. In my book you can see the proof. For ideal gas, you have something called internal energy for ideal gas can be only depends on temperature and degrees of freedom. So you have a degrees of freedom. So these are called active degrees of freedom. And times, for each degree of freedom, you have half kBT per molecule. This is per molecule per degree of freedom times the number of molecules you have. So this is a formula you should memorize, and you should know how to get degrees of freedom. And if you write down in other ways, it can be number of moles times gas constant times T, and the T is in Kelvin, absolute temperature. So we have a helium. The degree of freedom depends on what type of molecules are. So degrees of freedom for monoatomic gas, ideal gas, or any gas monatomic. So like helium, each molecule is just one atom. So each atom can have three, center of mass of the atom can move in three directions. So this is kinetic energy, means 3 degrees of freedom. If I have a nitrogen gas, then each molecule has 2 nitrogen atoms. So center of mass, it still has 3 degrees of freedom. So kinetic energy is 3 degrees of freedom. But then this can actually rotate about this axis with non-zero moment of inertia, rotate about this axis, non-zero. But if it rotates about this, there's 0 degrees, so that doesn't count. So 2 rotation degrees of freedom. And then there is a the bond between 2 atoms, like force of attraction, actually can vibrate. So this almost like a, as if a spring was attached to this, it can vibrate around there. So there's a vibration degree of freedom. So there's like a together all there's a 6 degrees of freedom, but at this vibration turns on at high temperature. So at regular temperature like room temperature, you'll have only 5 degrees of freedom active. So in this formula for nitrogen, when you do this problem for nitrogen, instead of 3, we can use 5. So that answers the number 2 here. Okay, so that's this much you have to know before we can do problem B. And so I'm going to use this. I'm going to use this to solve the problem. So let me clean up, and then we get all the calculations. Okay, so for B, we're going to use Q of this. The process that we're looking at is equal to delta U 8P minus Q, W B. So this will simply be df equals to 3 here, so this is going to be 3 over 2 nRT dB minus 3 over 2 nRTA minus WAB. Yeah, A to B. So this is, you can see that this can be equal to P times VB, and this is equal to P times VA, because for ideal gas we also have PV equals to nRT at any point. So for A you have A, at B you have B, RTB. So I can see over here is 3 over 2 PB PA. So PB equals to PA. So this just turns out to be 3 over 2 PA VB minus VA minus WAB, and this is how much work was actually done. So this actually equals to half. So this turns out to be half times whatever I found. Let's work it out. Okay, so 3.5, and this whole thing is PA is 1 atmosphere, and this is 40 minus 20 liter, and WAB is minus 2000, and so this is 3 over 2, and this actually is equal to 2000 minus plus 2000. So this is 3/2 plus 1 is 5/2 times 2000 joules. So this is actually 5000 joules. So there's a 5000 joules actually went in to take it from A to B, and this is plus, so heat has to flow in. So QAB we found is 5000 joules. Okay. How about B to C? Okay. So you have a QBC will be a delta UBC minus WBC, but this is 0, and this will be 3/2 nRTC minus 3/2 nRTDB. After nRTC, this whole thing is PCBC, and this is equals to PBBB. So we have 3/2 common. So PCVC minus PVVB. So 3/2. P is a 3 atmosphere times 40, and then you have 1 atmosphere times 40, so liter atmosphere. So this is not 0. See, although W was 0, Q is not 0. So this is equal to 2 times 40, so 3 over 2 times 2 times 40 liter atmosphere, and that's 120 liter atmosphere, and that's going to be 120 joules. So 12,000 joules. Actually, a whole bunch of heat went in. So heat went in to heat up this. Heat went in to heat up from A to B. Now C to A, you will have some loss of energy, loss of heat. Okay. So C to A. How do we get C to A? So QCA will simply be delta UCA minus WCA. So WCA is this, already know. So QCA, this is going to be 3/2. Doing all this calculation is going to be PA VA minus PC VC minus and that's a 4,000. There was a plus here, so 4,000 joules. Now this is PA is 1 atmosphere and VA is 20 I mean, and PC is 3 atmosphere, and this is VC is 40. So this is 3/2 20 minus 120 liter atmosphere minus 4,000 joules. So these are different units. We already know that I have to multiply by 100 to get to the joules. So what do we get here? 300. So this is 100. So the 50. So this is 150, and then 2 zeros minus 4,000. Now everything in joules. So I have 11,000 joules. This actually is minus and minus. So minus 19,000 joules, not that 50. Both of them same. You can see I'm going to get a negative here, so this should be negative here, and this was negative there, so minus 19,000 joules. Okay. Okay, so for the cycle, all the around, I just have to add up. So you have a 17 minus 19 is minus 2,000 joules. And it makes sense, because if I go in a cycle, I go from A back to A, then what is delta U? Delta U is U at A minus U at A, so that's 0. Delta U is 0. So this is in the cycle. That means this should equal to Q cycle plus W cycle. So if this is 0, then Q cycle should be equal to minus W cycle. And you can see W cycle is 2000, Q cycle is this. And this kind of very important observation I made, and you should notice that whenever you're in a cycle, you end up with the same state. You start from here, went somewhere, and then came back to the same place. Then the energy over the cycle energy change over the cycle should be 0. Whatever you took some energy from the environment, you get back to the same amount of energy to the environment over the cycle. That must be the case, okay? So we find the work and find the heat over in the cycles with B. Now, so we're done with one, and then there is this question about, had I done with nitrogen, what will happen? So this one we kind of addressed a little bit earlier. So for nitrogen, active degrees of freedom will be Cm, kinetic energy of Cm, that gives me 3, that's always active, and then I have a rotation of each molecule 2 axis, where the moment inertia is not 0, is 2, and at ordinary temperatures, vibration degree of freedom is inactive. If very high temperature, even that will come active. So we just assume that this ordinary temperature, we can find out what temperature it is by just looking at, let's look at the temperature at A. How much was that? PA VA over NR. So if I look at just temperatures, if I can actually ignore this, and it says ignore it, so let's see, PA was 1, and that was 20 times 100, make it joule, and N is 2 moles, and then R is 8.31 in terms of SI unit. So you can see this is 10, and so this is like 1,000. I just cancel this with this just for the sake of it's like 1,000 K, a little bit more than 1,000 K. So we just, this is ordinary, and at this temperature you have we'll just say, oh no, this should be 10. So this is like 100K, 110K or something like that, and this is okay. So this is assumption is okay. All right, so you should work out. So delta U now will be 5, not 3, 5 times half nRT for the nitrogen. And you can see this will feed into all the Q's, right? So QAB will be 5 half PB VB minus PA VA minus WAB. So instead of 3 half, you're going to be 5 half. And so you can see what the answer will going to be now. 5 half, and this was 2,000 plus 2,000. So you have 5,000 plus 2,000 is 7,000. So instead of 5,000, you can have 7,000, and you can work out the other things similarly. Okay, don't forget to hit the like button, okay, and subscribe if you haven't subscribed already. Check out my website, physicsbootcamp.org, and thank you. Take care. Bye.